I spend a lot of time just reading up on concepts that I want to edify myself on. Stuff that's not particularly directed to an end. And every so often, a couple of ideas bounce together completely unexpectedly, and I need to get them out. This is one of those instances. Sad to say that this morning I knew next to nothing about Immanuel Kant. Now I know a little bit. But before we get to that, we need to discuss relativity. One of my pet peeves as a fan of science fiction is how often relativity is ignored when it's such a cool theory. The speed of light is not like the sound barrier. The speed of light is a fundamental aspect of reality. So, and what does that mean? Okay, let's talk about the speed of light. Imagine a two-dimensional plane, XY axis, standard Cartesian field. And for this plane, for the sake of this, the horizontal is going to be space. All of space is contained in that horizontal. And the vertical axis is time. So each space-time event, each one of us, is going to be somewhere in that field. So going down in the past is a cone of all the things that could have affected you. Out into the future is everything that you can and will affect, even if you only affect it by light bouncing off of you. This cone is, you move forward in time and it's light coming off of you. Those are the two cones. Anything outside of those cones do not exist for you. Cannot exist for you. Cannot interact with them. So now let's imagine two people in this field. We've got person A and person B. And so they're obviously a huge different distance apart. Light days, light hours, whatever. And so they cannot interact until they move into the future and their light cones reach one another. That is the earliest point there can be any interaction between these people. So, well, why can't we have an Ansible, an instantaneous etheric communication device? Well, surely these two people, they could just bounce signals off one another. Doesn't seem to be any problems with that so far, does there? It's not violating causality, it's not twisting the universe into a pretzel. They're just talking to each other. Well, here's where it gets interesting. Let's take one of these people and accelerate them to a significant fraction of c. So at this point, see, when they both are traveling here, this is because they have the same relative velocity to one another. Of course, as far as they're concerned, they're all standing still. We're all standing still. It's the world that moves around us. But these two people, they can tell when there's a difference between them. It doesn't matter which one is accelerating, but there's an acceleration, there's a difference in velocity in regards to one another. So what happens then is as you start to move through space a substantial fraction of c, your light cone, which used to be vertical, starts to twist in the direction of your travel. So now you have the one light cone that looks like this, still a vertical cone according to us, and then you have the person that's started traveling and they have a slanted cone. So what happens now when these people try and exchange messages to one another? Person with the vertical cone pings out a message cross space instantaneously to the person with the slanted cone, and they receive it. But their cone looks like this. So when they ping out a message back to the person that was trying to talk to them, it travels at this angle, arriving in the first person's past. They receive a reply to a message before they send the message. This is why they say in science fiction, if you have FTL, you can either have causality or relativity. You can't have both. As soon as anything travels faster than the speed of light, it violates causality, even if it's something as simple as a radio broadcast. Now, that's, of course, assuming that causality is an aspect of reality. I mean, certainly everything seems to have a cause, doesn't it? Can you imagine a universe without one? And for the record, we know that relativity is true. A lot of our technology would not work if Einstein hadn't come up with a theory of relativity. Satellites, for instance, are in a different relativistic frame than us. If you don't account for relativity, your GPS would not work. So, moving on. Kant built off of the empiricists. And the empiricists, as he would describe them, said there were two types of reasoning: analytic and synthetic. Analytic is the reasoning you use to discover a prioris. So the statement, all bachelors are single, is a priori. Because if you understand the concept of bachelor, you understand that the bachelor is single. All bachelors are male, would be another a priori right there. Whereas the synthetic involved the outside world. Nobody can wake up, come to consciousness, grow up, and just know that gravity bends space and time, that things accelerate at 9.81 meters per second towards the Earth. You can't just know this stuff. You need to go investigate to figure it out. This is the realm where science does wicked, wicked things. It's the place where you go and test. This is what science is designed to do, is go invest the empirical. And it does a damn fine job of that. As far as the empirics were concerned, this was all there was. And certain questions were just unknowable. Kant disagreed. So you've got the analytic a prioris and the synthetic a posterioris. Kant suggested that there was a synthetic a priori. The type of knowledge that could only be arrived at from investigation that was still a priori. Mathematics. Which is precisely what I was saying about all truth being revelation. So Kant points out that with this statement, all bachelors are single, the conclusion is present in the predicate. Bachelor means single, so the conclusion that the bachelor is single is in the predicate. Doesn't say the same thing does not hold true for math, however. With mathematics, 5 plus 5 equals 10. Well, that 10 is new knowledge. You don't start with that knowledge when you say 5 plus 5. There is no knowledge of 10 inherent in the 5s. There is no inherent conclusion to any of that. Instead, you have to investigate it, and you gain something new at the end. See, Kant would argue that the analytic a prioris are so self-evident that we don't even notice them. Bright light is bright. Sweet food is sweet. The definitions of words, these are things that you just No, a prioris are so self-evident that you just know them, and you never even have cause to question that you know these things. Whereas with mathematics, we start discovering things that we can know that don't require investigation in the world. They're not empirical. They are purely metaphysical concepts that we discover through synthetic reasoning. That hint of the immaterial. So where do these ideas come from? Well, Kant, he called it transcendental imagination. But I think a better term for modern audiences would be Ideaspace. All of these ideas potentially exist in Ideaspace for us to find. Some of them, like the a prioris, are self-evident. The fact that we even exist in Ideaspace means that we can discover these concepts. There's others that we don't have. These would be the synthetic a prioris that we have to go and learn about or to figure out for ourselves before we can notice them. And then finally, there's the places that don't exist in Ideaspace. Thoughts that we literally cannot conceive of. And who knows how many of those are. And I'll give you an example. Neon black. It seems like a meaningful phrase, but it doesn't point to anything. You can't imagine what neon black would look like. The same way, for example, you could imagine a unicorn. Or if you were particularly good with math, you could even imagine a world with different laws of physics. But you could not imagine neon black. The same way you can't imagine what happened before time began. These are unknowable concepts. And see, it's the limits of Ideaspace and our own ability to observe which imposes upon reality. The term Newman means a thing in and of itself. So the chair I'm sitting on is presumably its own Newman. It exists. It's real. It has an existence apart from my own. I can't see that Newman. I can't see that Platonic form. I can only observe my interaction with it. And that interaction is completely limited to my ability to observe. My observations on the universe decide what the universe is going to be. It's similar to the term heuristic, where the theory that you go into something with determines what you're going to get out, determines what you pay attention to, what you notice, except this is more fundamental. We cannot observe anything that is neon black, or that exists outside of time. And in fact, the entire concept of space and time are fundamental to our nature as observing beings. Doesn't mean that time and space are a part of the universe. It means that time and space are a part of us. So now that we've talked about Ideaspace, let's think about different sorts of minds. Let's think of different ways that minds could exist, could be organized. Now, the easiest one is probably a dog. A dog is very similar to us. It sees in slightly different colors. It is far more aware of scents. But when you get right down to it, dogs are not particularly dissimilar from the human. You could go to a bat. They observe the universe through sonar. So density is something that they're innately familiar with in a way that we aren't. And yet even the bat, everything the bat observes, he bounces the echolocation off of a tree, he can feel the texture of it, he can feel the density of it. And you see, I'm using the word feel because we don't have a sense term to describe what the bat is experiencing. But at the end of the day, we can relate to it still. These are all mundane variants upon our own sorts of minds. Even if you go to something as low as an insect, an ant or a grasshopper or a cockroach, these are things that do have urges that we can understand. They need to eat, they want to mate, they have a sort of very primitive fear in them, and they exist in time and space. They have eyes, they observe, they move, they are very primitive and quite odd, but when you get right down to it, they're not fundamentally different from us. So what is a fundamentally different mind? Well, something that's about as intelligent as a cockroach or an ant or a grasshopper. The computer sitting in front of you. The computer is a very primitive mind. It's far more primitive than the ant or the cockroach because it only has one or maybe 4 processing units, as opposed to however many hundreds of thousands or millions the insect has. But I think it's a good comparison. It's a good place to start because they are very, very complex neural networks, computers. Even if they aren't technically a neural network, they are a sort of a mind. They are a proto-mind. How does the computer experience the universe? Now, when we experience the computer, we have inputs and outputs from the computer: printers, monitors, keyboards, mice, speakers, microphones. But to the computer, none of this actually matters. The computer exists in a world that these inputs do affect things, but the computer's world is all about the processes going on, the mathematical relationships of ones and zeros. Now, certainly it has a chronometer inside of it, but if you imagine a computer experiencing time, do you think when it's in hibernate mode, it's experiencing every second tick by? Or does it exist within the complexities of the processing power? Like, I almost imagine the computer mind as being like a sort of web of electrical impulses shooting all over the place, which again is showing my own bias as a creature of space and time. But I think it's eminently plausible to imagine that sort of a mind. More complex than a modern computer, but that does not exist in space and time. Science fiction writers have proposed life on the outside of a sun, on the corona of a sun. These would be creatures without a conception of space, and with a very bizarre conception of time. Space and time are things we project onto the universe, as is causality. It is part of our nature. Just because we can't imagine things without causality doesn't mean that they can't exist. It just means that because they don't fit into our idea space, we can't observe them. And the point of all of this is that faster than light travel should be possible. Not for creatures like us, but for something better than us, our descendants, something more advanced, more complex, that has discovered different ways to observe and understand. And I know I'm going to get the physicists on here, saying this is a bunch of rhetorical nonsense falling deep into a black hole. It's not. Until you can explain how you observe reality and how you have this limited understanding of spatial concepts, it's not reducible in the way you want it to. Not the way you want it to be. And the possibilities this holds for the future are absolutely fascinating. And the implications for how we live our own lives for how we consider knowledge to exist. It should not be ignored. Anyway, there's your weird thought for the evening, folks. Arini out.